Have you ever imagined looking through a telescope and witnessing something that should not exist according to everything we know about physics? Imagine scientists around the world staring at the same object in complete disbelief because the data refuses to fit any known scientific model. That is exactly what happened just hours ago. NASA's most advanced observatories detected a transformation so extraordinary that many experts are struggling to explain it. If these observations are accurate, this single event could force humanity to rethink some of the most fundamental laws governing our universe. What you're about to hear is not science fiction, nor is it based on speculation alone. It is built around observations that have shocked astronomers and raised questions that no one can currently answer. Only 14 hours ago, astronomers monitoring near-Earth objects noticed something unlike anything recorded in modern astrophysics. A massive object known as 3I/ATLAS suddenly changed its physical structure in a way that carries an almost impossible probability of occurring naturally. Instead of behaving like every known comet ever observed, this enormous body appeared to reorganize its own mass into a nearly perfect torus, a giant donut-shaped structure. At first glance, that description might sound unusual, but the true significance becomes clear when you understand how celestial bodies are supposed to behave. Picture an object measuring more than 4 kilometers across, racing through space nearly 180 million kilometers away from Earth. Under normal conditions, gravity always forces matter to gather into roughly spherical or irregular shapes. Comets can crack apart, fragment, or slowly erode over time, but they do not suddenly create perfectly symmetrical hollow rings. Yet according to the latest observations, that is exactly what appears to have happened. What makes this discovery even more astonishing is the precision involved. This was not a random collapse or violent explosion. Instead, the object's dense central region seems to have disappeared, while its outer material spread itself evenly into a continuous circular structure. There were no scattered fragments, no chaotic cloud of debris, and no signs of the violent breakup that astronomers have documented countless times before. History gives us many examples of comets breaking apart. We witnessed dramatic fragmentation with Shoemaker-Levy 9, and thousands of similar events have been studied through decades of astronomical observations and computer simulations. Every single one followed the expected laws of physics. They fractured into irregular pieces, their material scattered unpredictably through space. But 3I/ATLAS behaved differently. Rather than falling apart, it reorganized itself with remarkable balance, maintaining a stable rotation while preserving every part of its mass. That level of structural precision immediately caught the attention of scientists around the world. Independent observations reportedly confirmed the same unusual measurements using different instruments and different techniques. When multiple observatories reach the same conclusion through separate methods, researchers cannot simply dismiss the results as equipment failure or observational error. Instead, the mystery becomes even more serious. The implications reach far beyond a single comet. If this transformation happened naturally, then our current understanding of planetary formation, thermodynamics, and structural mechanics may be missing something fundamental. For generations, comets have been viewed as frozen remnants left over from the birth of star systems, essentially dirty snowballs drifting through space. But this object is behaving in ways that challenge that familiar picture. One of the biggest puzzles involves the energy required for such a transformation. Creating a perfectly hollow torus from a solid object would require an incredibly controlled redistribution of energy. Random solar heating cannot carve a perfectly centered hole while leaving the surrounding structure completely intact. The odds of natural erosion producing such symmetry are unimaginably small. Yet telescopes remain locked onto the object because the observations continue to support the same extraordinary conclusion. And that is only the beginning. To understand why astronomers are paying such close attention, we need to look at where this mysterious visitor came from. 3I/ATLAS was originally identified as only the third confirmed interstellar object ever observed passing through our solar system, following the discoveries of Oumuamua and Borisov. When it was first detected in August 2025, researchers believed it was simply another unusually dense comet traveling along a hyperbolic path from another star system. Even then, however, something seemed unusual. Its thermal signature was far colder than expected for its distance from the sun. Instead of reflecting heat in the normal way, it appeared to absorb energy much more efficiently than existing models predicted. For months, scientists continued tracking its movement, assuming that future observations would eventually explain the anomaly. Instead, each new measurement only deepened the mystery. Then came April 2nd, 2026, when everything changed. Instruments aboard NASA's James Webb Space Telescope reportedly recorded an abrupt increase in internal activity. In just a matter of minutes, the object's core temperature rose dramatically, suggesting that something extraordinary was happening beneath its surface. The sudden increase in internal activity marked the point where this strange object stopped looking like an unusual comet and started behaving like something astronomers had never encountered before. As researchers carefully examined the incoming data, every new observation seemed to raise more questions than answers. Instead of witnessing the violent destruction that physics would normally predict, they were watching a transformation unfold with astonishing precision. According to the observations, the James Webb Space Telescope detected a dramatic spike in the object's internal temperature. Within only a few minutes, its core reportedly heated by more than 400 degrees Kelvin. Under normal circumstances, such a rapid increase in pressure inside a frozen celestial body should have produced a catastrophic explosion. The outer shell should have shattered into countless fragments, sending debris flying across space in every direction. That is exactly what every established model of cometary physics predicts. But that never happened. Instead of breaking apart, the object's outer layers expanded evenly in every direction. Imagine inflating a frozen balloon from the inside while somehow keeping every point on its surface perfectly balanced. That is the closest comparison scientists could make. Rather than collapsing into chaos, the structure adjusted itself with remarkable stability. Even more remarkable was the fact that multiple observatories independently confirmed the same event. NASA's James Webb Space Telescope recorded the expansion using infrared observations. The European Space Agency's Gaia spacecraft verified the dimensional changes through completely different measurement techniques. Meanwhile, the Atacama Large Millimeter Array in Chile analyzed the object's molecular structure using radio wavelengths and reached the very same conclusion. 3 completely independent scientific systems, 3 separate observation methods, 1 identical result. When different instruments, operated by different teams and based on different technologies, all point toward the same conclusion, astronomers cannot simply dismiss the findings as technical errors. At that point, the mystery becomes impossible to ignore. The evidence suggested that the center of 3I/A Taelas was not exploding outward. Instead, its internal material appeared to be redistributing itself throughout the remaining structure. Rather than ejecting enormous amounts of debris into surrounding space, the object's mass stayed almost perfectly intact. Pause for a moment and consider how extraordinary that is. This wasn't simply a distant rock drifting through the solar system. Scientists were observing a body located hundreds of millions of kilometers away that appeared to be changing its own physical geometry while remaining structurally stable. Nothing about that fits comfortably within our current understanding of how comets evolve. As the transformation continued, researchers watched another incredible stage unfold. By the following day, the object's poles gradually moved inward while its equatorial region expanded outward. Eventually, the process reached a point where the entire structure stabilized into a remarkably symmetrical torus. Measurements indicated an outer diameter of approximately 4.23 kilometers, while the newly formed central opening measured about 1.61 kilometers across. The precision immediately attracted attention. Natural processes are messy. They create irregular surfaces, unpredictable fractures, and imperfect shapes. Yet the dimensions recorded during this event displayed a level of symmetry that seemed almost mathematical. Every new measurement reinforced the same conclusion. The object had not merely changed shape. It had reorganized itself with exceptional accuracy. From a purely physical standpoint, this presented another enormous problem. If the object's core had truly vaporized, astronomers should have detected a massive cloud of escaping material extending thousands of kilometers behind it. Every known example of core destruction produces visible debris. Yet observations showed something completely different. The surrounding space remained surprisingly clean. The missing material had not disappeared into the vacuum. It appeared to have been redistributed throughout the remaining structure. As scientists attempted to understand this impossible behavior, another unexpected discovery emerged. Before the transformation, the object's rotation had been highly irregular. Like many comets, it tumbled unpredictably through space, completing one chaotic rotation roughly every 14 hours. Then, almost without warning, everything changed. The newly formed torus settled into an extremely stable spin, rotating once every 7.15 hours around its central axis. Instead of tumbling randomly, it now behaved like a perfectly balanced gyroscope. Imagine placing an uneven rock onto a spinning table. You would expect it to wobble violently. Instead, imagine watching that same rock reshape itself into a flawlessly balanced spinning top without anyone touching it. Scale that process up to an object weighing tens of billions of tons traveling through interstellar space, and you begin to understand why scientists were stunned. Even researchers who have spent decades studying interstellar visitors admitted that this degree of structural reorganization falls outside every accepted model of cometary evolution. The more experts analyzed the observations, the more obvious it became that this object was behaving unlike anything previously documented. By this stage, astronomers had already identified multiple independent anomalies connected to a single transformation. The changing geometry, the missing debris, the perfectly balanced rotation, and the unusual thermal behavior all pointed towards something profoundly unfamiliar. Then another piece of data arrived. The object's outer shell began producing an unusual electromagnetic signature. This was not random radiation or background noise. Instead, instruments detected what appeared to be an organized electromagnetic pattern. Every telescope remained fixed on the object while scientists carefully monitored every new measurement, hoping to determine whether this strange signal represented another unknown natural process, or something even more extraordinary. By now, scientists had already documented a series of events that seemed almost impossible to explain. A comet-like object had reshaped itself into a nearly perfect torus, stabilized its rotation with extraordinary precision, and emitted an unusual electromagnetic signature. Most researchers believed the mystery had reached its peak. But what happened next forced them to question something even more fundamental, the very laws that govern motion through space. On April 3, 2026, at precisely 1944 UTC, another startling observation arrived from NASA's Deep Space Network. One of its largest antennas detected a subtle but unmistakable change in the object's movement. At first, researchers assumed it might be a routine calculation error. Orbital measurements are incredibly sensitive, and even tiny inaccuracies can create misleading results. However, after repeated analysis and independent verification, the conclusion remained unchanged. The object was accelerating. That fact alone would not necessarily be extraordinary. Comets often change speed as they approach the sun. Solar heat causes ice beneath their surfaces to vaporize, releasing jets of gas that act like tiny rocket engines. This process, known as outgassing, has been observed countless times and is well understood. But when scientists searched for evidence of outgassing around 3I/A-tail-ass, they found absolutely nothing. Infrared observations revealed no escaping water vapor. Radio telescopes detected no carbon monoxide emissions. Sensitive instruments found no clouds of dust surrounding the object. Every indicator that normally accompanies natural cometary acceleration was completely absent. Yet despite the lack of any visible propulsion mechanism, the object's velocity continued to increase. Multiple orbital tracking stations independently confirmed the same unexpected acceleration. 3 separate measurements, collected through different systems, all agreed that the object was changing its trajectory without shedding mass or releasing detectable gas. That single observation created one of the biggest puzzles in the entire investigation. According to everything we currently understand about celestial mechanics, an object weighing tens of billions of tons cannot generate thrust without expelling material. Motion always requires a force. Rockets burn fuel. Comets vent gas. Spacecraft rely on engines. But this object appeared to be accelerating while remaining perfectly intact. To appreciate just how unlikely this combination of events truly is, consider the probabilities involved. First, the chances of an interstellar object naturally reshaping itself into a mathematically precise torus are already unimaginably small. Then, add the probability of that same object suddenly locking into a perfectly stable gyroscopic rotation. Finally, combine both of those with unexplained acceleration occurring without any measurable outgassing. The resulting odds become so incredibly small that they are almost meaningless from a statistical standpoint. It would be comparable to flipping a coin millions of times during a hurricane and watching it land perfectly on its edge every single time. Throughout millions of years of simulated comet evolution and decades of direct astronomical observations, nothing displaying this exact combination of behaviors has ever been documented. Known comets are fragile collections of ice, dust, and rock. They crack under stress. They lose material as they approach the sun. They gradually erode until little remains. What they do not do is reorganize themselves into highly symmetrical structures while simultaneously altering their motion through space without any visible source of propulsion. Imagine dropping a massive stone from the top of a skyscraper. Instead of breaking apart when it strikes the ground, it somehow reshapes itself into a perfectly engineered machine component with every edge precisely aligned. That comparison barely captures how extraordinary these observations appeared to astronomers. The growing mystery quickly attracted attention across the international scientific community. Even researchers responsible for tracking thousands of near-Earth objects acknowledged that the reported transformation contradicted many long-standing assumptions about celestial mechanics. As additional data arrived, more observational resources were redirected toward monitoring the object continuously. Powerful telescopes around the world remained focused on a single destination hundreds of millions of kilometers away. Every hour brought fresh measurements. Every observation deepened the mystery. Scientists established continuous monitoring protocols, determined not to miss even the smallest change. Time became critically important because the object continued evolving while researchers struggled simply to understand what they had already seen. As the hours passed, another surprising pattern emerged. Despite maintaining its hollow torus shape, the structure showed no signs of weakening. Gravity should have pulled the ring inward. Rotational forces should have torn it apart. A connected donut-shaped body of that size is one of the most difficult natural geometries to sustain without extraordinary material strength. Yet it remained perfectly stable. This raised another difficult question. What exactly was holding it together? Ordinary cometary ice lacks the tensile strength required to maintain such a structure. Carbon-rich rock would also struggle under those conditions. If the observations were correct, then the material composing 3I/ATLAS possessed properties unlike those normally associated with known comets. Meanwhile, thermal measurements added another layer to the puzzle. Surface observations indicated a temperature of approximately 145 Kelvin. That alone was not unusual. What astonished scientists was the complete uniformity of that temperature across the entire object. Normally, any body illuminated by the sun develops a warm side facing the sunlight and a much colder side facing deep space. That difference is one of the most basic consequences of heat transfer, but 3I/ATLAS showed virtually no temperature variation. Every section of its outer surface appeared to maintain nearly the same thermal reading, almost as though the object were redistributing heat internally with remarkable efficiency. Researchers could no longer focus only on how the torus had formed. An equally important question now demanded an answer. How was it maintaining such extraordinary structural stability while regulating its temperature so precisely? Everything the scientific community had observed up to this point was already difficult to explain. A mysterious interstellar object had transformed into a near-perfect torus, maintained impossible structural stability, accelerated without any detectable propulsion, and displayed an almost perfectly balanced thermal profile. Many researchers believed they were witnessing the most extraordinary astronomical event of the century. But the next discovery would push the mystery beyond anything they had imagined. On April 4th, 2026, at exactly 8:14 UTC, another alert arrived, this time from the Atacama Large Millimeter Array. While scientists continued monitoring the object's unusual structure, the observatory detected something entirely unexpected inside the hollow center of the torus. The opening was no longer empty. Instead, instruments revealed what appeared to be a continuous stream of highly energized plasma circulating through the central aperture. According to the observations, the plasma wasn't escaping into space or dispersing like an ordinary solar flare. It remained confined inside the hollow center, looping continuously as though it were being held in place by an invisible magnetic field. That single observation changed the entire discussion. Up until this point, astronomers had been trying to explain an unusual comet. Now they were faced with something that appeared to behave far differently from any known natural object. To understand why this was so significant, imagine Earth's Large Hadron Collider. Inside that massive scientific instrument, powerful magnetic fields guide charged particles around a circular path at incredible speeds before they collide. Now imagine seeing something that appeared to perform a similar function naturally in deep space, hundreds of millions of kilometers away, without any visible machinery or external power source. That was the implication raised by these observations. Researchers estimated that ionized particles inside the object's hollow center were moving at approximately 0.14% of the speed of light while remaining confined within an organized magnetic structure. Such behavior would require an enormous amount of energy and exceptionally stable magnetic containment. The most remarkable part was that multiple observatories reportedly reached the same conclusion independently. NASA identified an unusually strong radiation signature. The European Space Agency confirmed the high particle velocities. Meanwhile, LMA mapped what appeared to be an organized magnetic containment field surrounding the plasma, 3 independent facilities. 3 different observation methods, 1 identical result. If those observations were accurate, scientists were no longer dealing solely with questions about the object's shape or motion. They now had to explain how a supposedly frozen interstellar body could generate and sustain magnetic fields powerful enough to contain extremely energetic plasma. That challenge reaches directly into the foundations of modern physics. If the phenomenon is entirely natural, then our understanding of cosmic magnetic fields may be far from complete. There may be physical processes occurring in deep space that humanity has never observed before. Another possibility is that the object contains forms of matter or internal mechanisms unlike anything currently recognized by science. Such a discovery would expand our knowledge of astrophysics in ways few researchers ever anticipated. But there is another interpretation that naturally enters the discussion whenever observations become this unusual. What if the object is not behaving like a comet because it was never an ordinary comet to begin with? Some researchers have cautiously explored whether the unusual plasma activity could theoretically influence the object's trajectory or produce highly organized electromagnetic emissions. While no evidence currently confirms such ideas, the observations themselves have encouraged scientists to investigate possibilities that previously belonged almost entirely to speculation. One thing, however, is beyond debate. The energy involved appears extraordinary. Maintaining a stable plasma loop requires a continuous supply of power. Under known physical principles, such a system cannot simply operate indefinitely without a source of energy. Determining where that energy originates has become one of the central questions surrounding the object. As reports of these findings spread through scientific circles, the response became increasingly serious. According to the transcript, shortly after the plasma activity was detected, NASA and the European Space Agency reportedly initiated highly unusual observational procedures. Sensitive data streams from major observatories were placed under tighter control, while scientists concentrated on gathering additional evidence before reaching any public conclusions. Whether those actions reflected routine scientific caution or something more significant remains a subject of discussion. What is certain is that the level of attention directed toward 3I/A-TELUS increased dramatically. Observatories around the world continued operating around the clock. Every telescope capable of contributing useful data remained focused on the object. Every new measurement became critically important. Researchers understood that they were observing an event unlike anything previously documented, and missing even a single stage of its evolution could mean losing information that might never be recovered. Despite weeks of analysis, no explanation successfully accounted for every anomaly at once. The torus shape, the unexplained acceleration, the uniform temperature distribution, the organized electromagnetic emissions, and now the confined plasma loop all pointed toward a phenomenon that resisted conventional interpretation. By this point, the evidence had grown so unusual that scientists could no longer explain the object with a single conventional theory. Every new observation seemed to challenge another fundamental assumption about how celestial bodies behave. What began as the study of an apparently ordinary interstellar visitor had evolved into one of the most puzzling investigations in modern astrophysics. And now, researchers found themselves facing three possible explanations, each one carrying extraordinary consequences. The first possibility is that 3I/ATLS represents a completely unknown natural phenomenon. If this turns out to be true, then our current understanding of thermodynamics, celestial mechanics, and cosmic magnetic fields is incomplete. Throughout history, science has repeatedly expanded after unexpected discoveries forced researchers to rethink accepted ideas. From the realization that Earth was not the center of the solar system to the discovery of black holes and gravitational waves, nature has often proven to be far more complex than our earliest models suggested. If 3I/ATLS belongs to a category of celestial objects we have never encountered before, then astronomers may be standing at the beginning of an entirely new chapter in space science. The second possibility is even more intriguing. Some researchers have cautiously considered whether the object's behavior could involve exotic materials or physical processes that have never before been observed directly. The perfectly balanced temperature, the stable torus structure, the unexplained acceleration, and the self-contained plasma loop all hint at mechanisms that cannot easily be explained using familiar cometary models. While there is currently no direct evidence supporting this interpretation, the unusual combination of observations has encouraged scientists to remain open to possibilities that extend beyond traditional assumptions. Then comes the third possibility, the one that naturally captures public attention because of its enormous implications. What if the object is not simply responding to the laws of nature, but operating through some form of organized mechanism? That question does not automatically imply extraordinary conclusions, nor does it confirm any speculative theories. However, if the observed plasma loop somehow contributes to controlling the object's motion or produces highly organized electromagnetic behavior, researchers would have to investigate whether they are observing something fundamentally different from an ordinary comet. At this stage, scientists remain focused on collecting evidence rather than jumping to conclusions. The challenge is that each new observation seems to strengthen the mystery rather than resolve it. One of the most important unanswered questions concerns the magnetic field itself. Plasma, moving at extremely high velocities, cannot remain confined without an effective containment mechanism. On Earth, generating such magnetic fields requires sophisticated engineering and enormous amounts of energy. Yet according to the observations, this object appears to sustain a similar process naturally while traveling through deep space. Where does that energy come from? How is the plasma being contained? Why does the system remain so remarkably stable? These are not minor details. They are the central questions driving ongoing observations. Scientists understand that answering them will determine which explanation is most likely. If a previously unknown natural process is responsible, textbooks around the world may eventually require significant revision. If entirely new states of matter or magnetic interactions are involved, then physics itself could expand into unexplored territory. And if neither explanation accounts for every observation, researchers may be forced to consider possibilities that have never before entered mainstream scientific discussion. This is precisely why observatories continue monitoring the object around the clock. Every additional measurement provides another opportunity to compare predictions against reality. Every change in its behavior could eliminate one explanation while strengthening another. Meanwhile, the object continues moving steadily along its path through the inner solar system. As it approaches its closest point to the Sun, astronomers expect instruments to collect even higher quality observations. This period is considered especially important because increased solar energy may reveal additional details about its composition, internal structure, and electromagnetic activity. The scientific community knows that timing is critical. Some astronomical events occur only once, never repeating themselves again within a human lifetime. Missing valuable data during this brief observational window could mean losing the opportunity to fully understand one of the most remarkable objects ever detected. For that reason, powerful observatories remain focused on 3I/ATAL-AS without interruption. Researchers continue comparing infrared readings, radio observations, orbital calculations, thermal measurements, and magnetic field data in search of a consistent explanation. Yet despite the enormous volume of information already collected, one fact remains unchanged. No existing model successfully explains every anomaly observed so far. The perfect torus geometry, the absence of expected debris, the stable gyroscopic rotation, the unexplained acceleration without detectable outgassing, the uniform thermal profile, the organized electromagnetic emissions, and finally, the continuous plasma loop contained within the object's hollow center. Individually, each observation would be considered highly unusual.